Rosetta is a space mission on its way to observe comet Churyumov Gerasimenko, and we're going to be studying that comet as it goes around the sun in its comet's journey. Our study of this comet will help to inform us about our biggest mysteries. Where did this comet form? And what can this comet tell us about how our solar system formed?
The Rosetta mission will help us put the origins of the solar system into a galactic context. We're interested in how we turn the gas and dust that was the early solar system into the solar system we see today. In particular, we're interested in how the planets acquire their compositions. How do we make rocky planets? How do we make gas giant planets, icy planets? And then we're also interested in the distribution of these planets, which ones were migrating when during the construction of the solar system. Comets are a key to understanding that kind of activity.
How did it all begin? We start with this ginormous molecular cloud. The molecules that form our solar system begin to condense together with a sun, a proto-sun at the center, and protoplanets scattered throughout this dusty and completely filled disk. And right at this time, we start to ask ourselves, were new chemicals introduced into our solar system at that early formative stage?
We think it has something to do with massive stars that are the sister stars to the sun, which throw out these giant winds, and in these winds are these radioactive elements. And it's these radioactive isotopes that tell us something about the birth environment of the sun because of this connection with our sister stars.
We think that something happened to cause a whole bunch of debris to come rapidly forward from the outer solar system into the inner solar system. And did that bring water to the inner solar system? Could that have brought part of the composition of our oceans today on Earth?
We need to know where that water came from to understand whether or not there's Earths elsewhere in the galaxy.
We have a lot of questions about, did we have planets moving around in the outer solar system?
It's possible that Uranus and Neptune actually swapped positions and excited dynamically the Kuiper belt.
Was that the event that caused a huge amount of scattering that came forward and hit the inner solar system? A second idea is perhaps Jupiter might have migrated all the way forward and then turned around and gone back out again to where it is now.
And it's exciting to think about the fact that the planets that we all learn in grade school, where they are, all line up, not because that's where they formed, but that's where they rested after a sort of violent beginning.
Rosetta will help us to either validate or refute some of these theories.
This is a window into our roots, literally how we get from stardust to people. You get there through the solar system formation mechanisms. To me, the reason to understand the origins of the solar system is to know whether or not we're normal, whether or not our solar system is a common phenomenon in the galaxy.
Are we alone in the universe, or can we expect life can be found anywhere?